Hello viewers, we learned certain facts regarding roots of quadratic equation in our previous lesson. What are those? We learned that if ax square plus bx plus c equal to 0, a not equal to 0 is a given quadratic equation, then d is equal to b square minus 4ac is called its discriminant. If d is greater than 0, then the equation will have real and distinct roots alpha and beta given by alpha is equal to minus b plus under root of b square minus 4ac upon 2a and beta is equal to minus b minus under root of b square minus 4ac upon 2a. If d is equal to 0, then the equation will have real and equal roots, namely minus b upon 2a. If d is less than 0, then the equation will have no real roots. What else did we learn in that lesson? We also learned to find the sum and the product of the roots of a given quadratic equation without actually finding out the roots. That is, given a quadratic equation ax square plus bx plus c equal to 0, a not equal to 0, sum of its roots will be alpha plus beta, that is minus b upon a, which is nothing but minus coefficient of x upon coefficient of x square, and product of the roots will be alpha into beta, that is c upon a, which is the constant term upon coefficient of x square. Now, given equation, we know how to find out its roots. For example, in order to find out the roots of the equation x square minus 7x plus 6 equal to 0, first of all we will factorize it, and the factors of this equation will be x minus 6 into x minus 1 equal to 0, which gives us the roots of this equation as x is equal to 6 and x is equal to 1. But suppose we have to construct an equation whose roots are given as 6 and 1, then what do we do? Naturally, we will think of the factors which gave us these roots. That is, if the roots of the equation are given as 6 and 1, then the factors will be x minus 6 and x minus 1. When we multiply them and equate them to 0, then we get the equation x square minus 7x plus 6 equal to 0. Similarly, suppose we have to construct an equation whose roots are given as 5 and 2. Then again we have to think of the factors which give us these roots, that is x minus 5 into x minus 2, and when we multiply them and equate it to 0, we get the equation as x square minus 5x minus 2x plus 10 equal to 0. Hence, the equation is x square minus 7x plus 10 equal to 0. But can we obtain these equations by any shortcut method? Let us see. Observe the equation x square minus 7x plus 10 equal to 0. We were given that the roots of this equation are 5 and 2. Therefore, the sum of the roots of this equation will be 5 plus 2, which is equal to 7, and the product of the roots of this equation will be equal to 5 multiplied by 2, which is equal to 10. Observe that this sum minus times this sum is the coefficient of x here, that is minus 7 is the coefficient of x here, and the product of the roots, that is 10, is the constant term here. So, our equation should become x square minus sum of the roots multiplied by x plus product of the roots equal to 0. Let us consider another example. Suppose we have to construct an equation whose roots are given as 7 and 4. Again, the factors of these giving these roots will be x minus 7 into x minus 4 equated to 0. We get the equation x square minus 11x plus 28 equal to 0. Again, observe that the roots of this equation was given as 7 and 4. So, sum of the roots of this equation will be 7 plus 4 equal to 11, and the product of the roots of this equation will be 7 into 4, that is equal to 28. What do we observe? We observe that minus times the sum of the roots here is the coefficient of x, and the product of the roots, that is 28, is again the constant term here. So, again we can say that given the roots of the equation will become x square minus sum of the roots into x plus product of the roots is equal to 0. Consider the equation ax square plus bx plus c equal to 0, where a is not equal to 0. This equation can also be written as x square plus b upon a into x plus c upon a equal to 0, which can be further written as x square minus b upon a into x plus c upon a equal to 0. Now, observe here that the coefficient of x here is nothing but minus b upon a, which is minus sum of the roots, and the constant term here is c by a, that is product of the roots. So, given the roots of a quadratic equation, the equation becomes x square minus, as per this equation I am writing here, x square minus sum of the roots into x plus product of the roots equal to 0. Now, let us construct a quadratic equation, one of whose roots is 2 minus under root of 7. In quadratic equations, roots always occur in conjugates. So, if one of the roots of the quadratic equation is 2 minus under root of 7, then the other root will obviously be 2 plus under root of 7. So, now if we have to construct the quadratic equation whose roots are 2 minus under root of 7 and 2 plus under root of 7, then first of all we have to find out the sum of the roots. The sum of the roots in this case will be 2 minus under root of 7 plus 2 plus under root of 7, which is equal to 4, and the product of the roots will be equal to 2 minus under root of 7 into 2 plus under root of 7, which is equal to 4 minus 7, that is equal to minus 3. And hence, as per our earlier result, the equation will become x square minus sum of the roots, that is 4 into x, plus product of the roots, that is minus 3, equal to 0, or we can further write it as x square minus 4x minus 3 equal to 0. Thus, we found that given a quadratic equation we can find out its roots, and alternately if the roots of a quadratic equation are given we can find out the equation itself, or we can construct the required equation. Now, sometimes we may be given one equation and we have to construct another equation whose roots are related to the roots of the given equation. For example, suppose we are given the equation 2x square minus 7x plus 6 equal to 0. Suppose we have to construct another equation whose roots are twice the roots of this given equation. Now, one way to solve this equation will be to find out the roots of this given equation, double it, and then find out the sum and the product of the roots of the required equation and then construct the equation. Don't you think that will be a very lengthy method? So, let us try to find out a shortcut method. Now, we are given this equation 2x square minus 7x plus 6 equal to 0. Let the roots of this equation be alpha and beta. Then sum of the roots of this equation will be equal to alpha plus beta, which is equal to minus b upon a, that is minus 7 upon 2, which is equal to 7 upon 2, and the product of the roots of this equation will be equal to alpha into beta, which is equal to c upon a, that is 6 upon 2, which is equal to 3. What do you think will be the roots of the required equation? Naturally, they will be 2 alpha and 2 beta. So, the sum of the roots of the required equation will be equal to 2 alpha plus 2 beta, which is equal to 2 times alpha plus beta, that is 2 times. Now, we know that alpha plus beta is equal to 7 upon 2. So, we can replace alpha plus beta by this value. So, we get 2 times 7 upon 2, that is equal to 7. Also, product of the roots of the required equation will be equal to 2 times alpha into 2 times beta, that is equal to 4 times alpha into beta, but we know that alpha into beta is 3. So, replacing alpha into beta by this 3 here, we get 4 multiplied by 3, which is equal to 12. So, now we have the sum of the roots of the required equation as 7 and the product of the roots of the required equation as 12. So, can we construct this equation now? Yes, the equation in this case will be x square minus sum of the roots of the new equation is 7. So, 7x, product of the root of the new equation is 12. So, that is 12 equal to 0. So, this is our required equation. Now, suppose we are given an equation 3x square minus 7x minus 6 equal to 0, and we have to construct another equation whose roots are reciprocal of the roots of this equation. So, what do we do? Again, let us suppose that the roots of this equation be alpha and beta. Then sum of the roots of this equation will be alpha plus beta, which is equal to minus b upon a, that is minus of minus 7 upon 3 which is equal to 7 upon 3, and product of the roots of this equation will be c by a, that is minus 6 upon 3, which is equal to minus 2. What do you think will be the roots of the required equation? Naturally, they will be 1 upon alpha and 1 upon beta, because they are reciprocal of the roots of the given equation. So, sum of the roots of the required equation in this case will be 1 upon alpha plus 1 upon beta, that is equal to, taking LCM alpha into beta, we get beta plus alpha, or it can also be written as alpha plus beta upon alpha beta. Now, from this earlier result, we have alpha plus beta is 7 upon 3 and alpha into beta is minus 2. So, replacing alpha plus beta by 7 upon 3 here and alpha into beta by minus 2 here, we get the sum of the roots of the required equation as 7 upon minus 6, or I can write minus 7 upon 6. Also, product of the roots of the required equation will be 1 upon alpha into 1 upon beta, that is equal to 1 upon alpha into beta, and as we already know that alpha into beta is minus 2. So, replacing alpha into beta by minus 2, we get 1 upon minus 2 as the product of the roots of the required equation. So, now we have the sum and the product of the roots of the required equation. Can you construct the equation now? Yes. The equation in this case will be x square minus sum of the roots, that is minus 7 upon 6 into x, plus product of the roots, that is minus 1 upon 2 equal to 0. This can further be simplified and written as 6x square plus 7x minus 3 equal to 0, which is the required equation. Thus, we found that given one equation, we can construct another equation whose roots are related to the roots of the given equation. Now, sometimes we come across equations which are not of quadratic form. For example, 3z raised to the power 4 plus 4z square minus 4 equal to 0. As you can very well see, this is not of quadratic form. So, how do we solve such equations? Either we find a new way to solve such an equation, or we try to reduce it to quadratic form, so that we can solve it by the methods we know. Now, can we reduce this equation to quadratic form? Since the powers of z are even here, therefore, this equation can be reduced to quadratic form by the substitution x is equal to z square. So, that this equation becomes 3x square plus 4x minus 4 equal to 0. Now, this equation can be factorized because this is a quadratic equation, we know how to solve it. Factors of this equation will be 3x minus 2 into x plus 2 equal to 0, and we get the values of x as x is equal to 2 by 3 and x is equal to minus 2. But since we have substituted z square as x, therefore, replacing this x by z square here, we get z square is equal to 2 by 3 and z square is equal to minus 2. This is not possible because square of a real number can never be negative. So, we are left with only z square is equal to 2 by 3, and hence the values of z which we get from here are plus minus under root of 2 by 3. Therefore, the solutions of this equation 3z raised to the power 4 plus 4z square minus 4 equal to 0 are z is equal to plus 2 under root of 2 upon 3 and minus under root of 2 upon 3. Thus, we find that an equation of the form a z raised to the power 4 plus b z square plus c equal to 0 can be reduced to quadratic form by the substitution x is equal to z square. Consider the equation x plus 4 upon x is equal to 5, x not equal to 0. Let us simplify this equation and see what do we get. If we multiply x on the both sides of the equation, we get x square plus 4 is equal to 5x, which can be further written as x square minus 5x plus 4 equal to 0. Oh, this is already a quadratic equation. So, we know how to solve such a quadratic equation. Can you tell what will be the solutions of this equation? Yes, this can be factorized as x square minus 4x minus x plus 4 equal to 0, and the factors of this equation will be x minus 4 into x minus 1 equal to 0. That gives us the roots of this equation as x is equal to 4 and x is equal to 1. Thus, we find that we can find out the solutions of the equations of the form ax plus b upon x is equal to c, where x is not equal to 0 by multiplying both sides of this equation by x. That gives us a quadratic equation. Now, consider the equation under root of 3x square minus 2 is equal to 2x minus 1. This is an equation involving one radical sign. One term has a radical sign. This equation will have roots if 3x square minus 2 is non-negative, and also the right hand side, that is 2x minus 1, is also non-negative. That is, if 3x square is greater than or equal to 2 and 2x is greater than equal to 1, or we can say if x square is greater than equal to 2 by 3 and x is greater than equal to half. Thus, you saw that we can find solutions of some equations which are not of quadratic form by reducing them to quadratic form. We will take up a few more such problems in our next lesson, but before we finish this lesson, let us have a quick recapitulation of what all we learnt in this lesson. We learned that given the roots of a quadratic equation, we can construct that required equation. We also learned that given an equation, we can construct another quadratic equation whose roots are related to the roots of the given equation. We also learned to find the solutions of an equation which is not of a quadratic form by reducing it to quadratic form. So, now here are some problems for you. Solve them. These problems will help you to clear the concepts which we have learnt here today. The problems are: if one of the roots of the quadratic equation x square plus 4x minus p equal to 0 is minus 7, find the other root. Also find the value of p. Next question is, if alpha and beta are the roots of the quadratic equation 2x square minus 7x plus 5 equal to 0, then find the value of alpha upon beta plus beta upon alpha. Also find the value of alpha cube plus beta cube. Next question is, if alpha and beta are the roots of the quadratic equation x square minus 8x plus k equal to 0, find the value of k such that alpha square plus beta square is equal to 40. Another question is, construct the quadratic equation whose roots are 3 and minus 6, 1 plus under root 2 upon 2 and 1 minus under root 2 upon 2. Another problem is, find the solutions of the equations 3z raised to the power 4 minus 7z square plus 2 equal to 0, y plus 3 upon y is equal to 4. Solve these problems and get them checked by a person of mathematics. In case of any problem, you can write to us. Thank you.